Ever wonder how those mighty medieval siege engines, the titans of the battlefield, could spectacularly fail? Well, let's dive into the ingenious, yet surprisingly fragile, world of trebuchets, catapults, and battering rams. Siege technology was a game-changer in medieval warfare, capable of bringing down the most formidable castle walls. But for all their brilliance, these war machines were far from perfect. Their designs concealed critical flaws that could turn a surefire victory into a catastrophic disaster in the blink of an eye. So, what were these hidden weaknesses? First up, the very materials they were built from. Imagine you've spent weeks, maybe months, constructing a colossal trebuchet. You're ready to launch, but the main throwing arm, made from green or rotten timber, suddenly splinters under the immense strain, or the ropes, woven from poor quality fibers, snap mid. Metal fatigue in crucial joints and pins was another silent killer. Engineers had to be expert lumberjacks and metallurgists, because one bad piece of wood or a single weak iron bolt could render the entire machine useless, or worse, cause it to collapse on its own crew. It was a constant battle against nature itself. Then there's the delicate art of balance and tuning. A trebuchet isn't just a giant seesaw. It's a finely tuned instrument of destruction. The relationship between the counterweight, the beam length, and the sling is a precise mathematical dance. Get the counterweight even slightly too light or too heavy, and your projectile either limply flops a few feet or flies wildly off. The same goes for the sling length and the release pin angle. A tiny miscalculation could mean the difference between hitting the castle gate and lobbing a boulder into an empty field half a mile away. It took immense skill and endless adjustments to get it just right, often under the immense pressure of active combat. Let's not forget the sheer mechanical complexity. These machines weren't simple levers. They were intricate assemblies of wheels, winches, gears, and ropes. More moving parts meant more things could go wrong. Axles could break, winches could jam, and gears could strip their teeth. Repairs were slow, difficult, and required specialized knowledge. A breakdown in the middle of a siege was a logistical nightmare. While the engineers were desperately trying to fix a broken part, the entire assault would grind to a halt, giving defenders precious time to regroup, repair their own damages, and rain down arrows on the exposed and vulnerable crew. Mobility was another massive headache. These engines were enormous and incredibly heavy. Torampoeto, Trebuchet, piece by piece, and assembling it on site was a monumental undertaking. And what if the terrain wasn't a perfectly flat, dry field? These behemoths would get hopelessly stuck in mud, bogged down in marshland, or find it impossible to navigate hilly or forested landscapes. A siege engine that looks terrifyingly effective on a blueprint is utterly useless if you get it into position. The ideal location for an attack might be tactically perfect, but geographically impossible to reach, forcing commanders to compromise and often reducing the engine's effectiveness. Of course, a machine is only as good as its operator. Operating a siege engine required a skilled and disciplined crew. It wasn't a job for just any soldier. The crew chief, or master engineer, had to calculate trajectories, account for wind, and manage the team with precision. A poorly trained crew was a danger to everyone. They could misfire, causing friendly fire incidents, or mishandle the powerful mechanisms, leading to accidents that could injure or kill the operators themselves. The rhythm of loading, aiming, and firing was a rehearsed choreography, and one wrong step could lead to disaster. These engines were also sitting ducks. They were large, slow, and completely exposed. Defenders weren't just going to sit back and watch. They'd target the machines and their crews with everything they had. Flaming arrows to set the wooden frames ablaze, heavy rocks from their own catapults, and daring raids to sabotage the engines up close. Sappers would even try to tunnel underneath them to collapse the ground they stood on. This meant siege engines needed their own dedicated protection details. further straining the resources of the attacking army. And finally, let's talk about the unsung hero of any medieval campaign: logistics. Building and maintaining these war machines required a constant and reliable supply chain. You needed vast quantities of quality timber, iron for fittings, and miles of rope. These weren't things you could just find lying around. If the enemy managed to cut your supply lines, your siege was effectively over. A trebuchet, without spare parts or a steady stream of projectiles, is just a very large, very expensive wooden sculpture. A famous example is the failure of a massive trebuchet during the siege of Acre in 1191. After weeks of bombardment, the immense stress on the wooden frame caused a catastrophic failure, with the main arm cracking and collapsing. This highlights a crucial lesson from the medieval era. Innovation is vital, but so is understanding the limits of your materials and design. These early engineers were pushing the boundaries of what was possible, and their successes and failures paved the way for modern engineering, reminding us that even the mightiest designs can have a hidden, fatal flaw. Thank you so much for watching. If you found this journey into medieval engineering fascinating, please give this video a thumbs up. And don't forget to subscribe and hit that notification bell for more deep dives into history. See you next time!